Hello students, welcome back to my channel Bonding with Chemistry. I'm Dr. Seema Singh and you're watching with me the important or expected question for the upcoming board examination schedule for 10th of May 2022. In this video, I'm going to discuss some of the questions from CBSE Sample Question paper that has been released in 2022 from the topic carbon and its compound. This video is also a closure to the question answers series from the chapter carbon and its compounds for the board examination. Now, my dear student, this is a sample question paper that I've downloaded from the website of CBSE for the term 2 2021-22. I'm not getting into the basic instruction. You know how your question paper is going to look like. From section A, let us look at all the questions that have been asked from the chapter carbon and its compound. The first question belongs to the chapter carbon and its compound. I'm going to write down C4 here, symbolizing the chapter number, chapter 4, carbon and its compound. The question says, the table shows the electronic structures of 4 elements. The elements are P, Q, R, S. The names are not given. And this is the electronic configuration 2,6, 2,8,1, 287 and 288. The question says, identify which element or elements, it could be one element or more than one element, will form covalent bonds with carbon. Now you know carbon is a non-metal. And in my previous videos, I've told you for formation of covalent bonds, you require two non-metals. Covalent bond is formed between two non-metals. So we are going to identify which out of the following elements are non-metals, and then that will be your answer. The first one is 2,6. Now some of the students will quickly identify that this is oxygen. Nobody's asked you to identify the name of the elements. You need to find out where you will have covalent bonding, right? Now it is having 6 electrons in its valence shell. You know metals, simple concept, metals lose electrons, whereas non-metals gain electron, right? Look at the first one. It has 6 valence electrons. To complete its octet, it requires 2 more electrons. So it's going to gain electron. So P is a non-metal. Fine. And it is going to form covalent bond with carbon. Fine. The next one is Q, 281. The valence electron are 1. So it is easier to lose 1 electron. And something or some element is losing electron, it is going to be metal. So this is not going to form covalent bond. It is going to form ionic bond. Moving on to the next one are 287. So it requires 1 more electron to complete its octet, and you can identify that this is chlorine. Alright. So again this is going to form a covalent bond with carbon. Moving on to the last one, 288. The outermost shell has 8 valence electron. The octet is complete. So this is going to remain inert. It will not react neither to form ionic bond nor to form covalent bond. So your answer is identify which elements. The answer is P and R. If somebody asks you to identify the name of the elements, so look at the electronic configuration, add the number of electrons, get the atomic number and then corresponding element. So 2 plus 6, 8. Oxygen. Your P is oxygen. 281, 11. This is your sodium. 287, 17. Chlorine. 288, 18. It's going to be your argon. Right? Now, half mark for writing probably P and half mark for writing R. Carbon reacts with an element in the above table to form several compounds. Give suitable reason. I have done this question in my previous videos and it's going to talk about the properties, 2 properties, main catenation. Although they have given you give suitable reason, you are supposed to write both the reason catenation and tetracovalency, a valency of 4 and catenation are responsible. They are the major reason for carbon forming so many compounds, millions of compounds. So catenation and tetracovalency, half mark for this, half mark for this. So it's a 2 mark question. Moving on to the next one. So shows part of the periodic table. The moment you will read the word periodic table, you will think that it is from periodic classification of elements. Look at the first part. Which elements would react together to form covalent compounds? So you know the elements have to be 2 non-metals. You all know on the left hand side of the periodic table you have metals. So this basically is a question from both periodic table as well as carbon and its compound. On the right hand side you have non-metals. Right? Here you will have a zigzag line which corresponds to metalloids or semi-metals. right? In the center also you have metals, but this you're going to study in higher classes. So Y and Z are non-metals. Therefore, which elements would react together to form covalent compounds? Y and Z, right? The other one is from periodic classification. I'm going to take up when I'm going to talk about the chapter periodic classification of elements. Moving on to the next section. Now you do not have any further chemistry question in section number A. We move on to section B. Look at question number 8. Choose an element from period 3 that's pertaining to periodic classification. I'm going to leave the question as of now. Come on to question number 9. I have done this question partially in my previous videos on isomerism. I've done this question in homologous series. This one I've done in Lewis dot structure. So let us quickly revise this question. This is an important HOTS question because it utilizes the concept of not only isomerism but electron dot structure plus the classification of hydrocarbons, general formula of hydrocarbons, right? And also your homologues, that is the lower and higher homologues or lower and upper homologues. How many isomers are possible for the compound with molecular formula C4H8? Now this C4H8 belongs to the general formula CnH2n, that of alkenes. CnH2n is also the general formula for cycloalkanes, family of cycloalkanes, cyclic compounds having carbon-carbon single bond, close structures. So let's start writing the number of isomers. If you want a detailed explanation, I repeat, you please refer to my previous video. How many isomers? The answer is 4. Most of the students will write 3, which is incorrect because they will leave this cyclobutane. So C4H8, what is C4H8? 4 carbon means but, and since general formula is that of alkene, butene. If I talk about cyclo member, cyclo, 4 carbon atom means but, and again butane, carbon-carbon single bond. So I'll draw isomers for butene, I'll draw isomer cyclobutane, and then find out how many isomers in totality exist. Butene means you have to have a carbon-carbon double bond in the structure. Let's go for the first isomer. 1, 2, 3, 4, and I put a double bond here. CH2, CH, CH2, CH3. Number 2, this 1, 2, 3, 4 numbering. I now put this double bond here between carbon atom 2 and 3. So I have CH3, CH, double bond CH, single bond CH3. They have the same molecular formula. You can count 3, 4, 5, 6, 7, 8. 8 hydrogen and 4 carbon. Number 3, I'm going to do 1, 2, 3 and a branch over here. I've given the explanation in my last video. CH2, CH3 and CH3. Fine. Number 4, cyclobutane. CH2, CH2, CH2 and CH2. This. So these are the 4 possible isomers. Look at the next part. Draw the electron dot structure of branched chain isomer. So you have to draw the electron dot structure of only this number 3 in the forms of dots and crosses to represent the corresponding electrons. So read the question well. How many isomers? 4. You get half mark for writing this. Nobody has asked you draw all the isomers. Draw the electron dot structure of branched chain isomer. You get 1 more marks, 1.5 for this portion. How will you prove that C4H8 and C5H10 are homologues? I have done this question earlier also. They both belong to the general formula CnH2n. Fine, they both have the general formula CnH2n and belongs to the family of alkenes. So if they belong to the family of alkenes, they are homologues because they have the same functional group, carbon-carbon double bond. Number 2, they differ by a CH2 unit. If you add CH2 to C4H8, you will get C5H10. Their molecular masses differ by a unit of how much? 14U. Carbon is 12, hydrogen is 1. There are 2 hydrogens, so 14U. They differ in the molecular masses by 14U unit. Then, since they have the same functional group, they are going to show similar chemical properties. You write any 2 of these points and you can prove that they are homologues. C4H8 is the lower homologue of C5H10, whereas C5H10 is the higher homologue of C4H8. I have done this in homologous series. Please refer to that part. Now look at this OR section. A carbon compound A having melting point 156 Kelvin and boiling point 351 Kelvin with molecular formula C2H6O is soluble in water in all proportions. Identify A and draw its electron dot structure. Also, give the molecular formula of any two homologues of A. Now, this is a hot question. Many students might think this is out of syllabus. No, my dear student. These data are given wherever they talked about the melting and boiling point of covalent compounds. Now, looking at this data, you don't have to remember this. If I convert them into degrees Celsius, minus 273, this is 78 degrees Celsius, and this is something around 117 degrees Celsius. You don't have to remember the value, just see it shows that they have very low melting point and boiling point. Fine. So obviously, those compounds which have low melting point and boiling point are covalent compounds. In your syllabus, only covalent compounds are there. So this A is a covalent compound. This data is given in your NCERT, wherever they mention the melting and boiling point of covalent compound. Some data are given, and there they have told that this belongs to ethanol. I'm not asking you to remember the table. Just let us see how we can find out the answer of this. We'll not panic and we'll just see how can we find out the answer. With molecular formula C2H6O is soluble in water in all proportions. Now we know that covalent compounds are not generally soluble in water. They are soluble in organic solvents, but we do have exception in the terms of sugar, urea, and ethanol, drinking alcohol, ethanol. Fine, with formula C2H5OH. All right. So C2H5OH is your drinking alcohol, which is soluble or miscible in water in all proportion. You take a small amount of alcohol or a large amount of ethanol, it is going to mix in water in all kind of proportions. So a compound A having melting point 156 Kelvin and boiling point 351 Kelvin, the molecular formula, this is soluble in water in all proportion. Identify A. So here you should have a little idea about this compound, and A here is nothing but ethanol. C2H6O, it's written there C2H6O. Actually what it is, you have your ethane, C2H6, this is your ethane. I'll tell you, if I remove one hydrogen and substitute it with functional group OH, what will I get? C2, I've removed one hydrogen, C2H5, and I've substituted it with OH. This is the functional group. You can also write it like C2, H total 5 plus 1, 6 and O. Alright, so this is alcohol, that is ethanol, and draw its electron dot structure. So let us draw the electron dot structure for this. I told you A is nothing but C2H5OH. Let's say you did not practice the electron dot structure for alcohol family because functional groups are not in your course. Now what to do? You remember it is derived from ethane. Ethane is nothing but CH3CH3. This is ethane. Your ethane is C2H6. I can say CH3CH3, right? I remove one hydrogen and substitute it with OH. Now convert all the bonds in dots and crosses and you get the electron dot structure of the corresponding alcohol called as ethanol. 2 carbon atom means eth. All carbon-carbon single bond ane. The suffix for OH group functional group is all, alcohol, to OL from there, OL. Now this is vowel followed by a vowel, so we drop the first vowel and the name is ethanol, right? So identify A is C2H5OH, ethanol, and draw its electron dot structure. You've done the first part. Give the molecular formula of any two homologues of A. Any two homologues, two consecutive, right? One after the other. So you have C2H5OH. To find its lower homologue, subtract CH2. So if I subtract CH2 from here, I get CH3OH. And if I'm going to add a unit of CH2, I'm going to get the higher homologue, C3H7OH. So C3OH is the lower homologue, C3H7OH is the higher homologue. With this question, I come to the end of this series of question answer, important board question answers from the chapter Carbon and its Compounds. If in case you feel that this video has helped you in any way, please like it. If you haven't subscribed to my channel yet, do please press the subscribe button. And for receiving the notification of a similar series from the chapter Periodic Classification of Elements, do please hit the notification button, that is the bell icon. See you in my next video. Until then, stay bonded, my dear learners.